whenever you're sharing your screen, and we're going to biology now, which has been mentioned a few times. And yeah. Thank you.
Okay.
Here we go.
Here's my introductory slide. Okay, so I guess we can all read, right? So I'm talking about the latticework of the cosmos and physiology. And I'm addressing the issue of local and that actually leads us into local and non-local consciousness as a paradigm shift. Let's see, I've got to get rid of this thing. Okay. So the cell membrane has evolved behaving like a Mobius strip, a published that paper in 2021, forming a conduit between the inside of the cell and the cosmos. Klein and Mayman have devised mathematics referred to as soft logic that combines real numbers and complex numbers, also forming a Mobius strip. I assume you all can hear me.
Yeah.
Okay. This convergence of evolution in mathematics is a paradigm shift. Please let me explain. Okay. It's not advancing. It's wrong. Okay, try that. So understanding consciousness is the most important thing we need to know, referred to as the explanatory gap. Where is consciousness? Evolution of physiology has been traced back to the unicell using cell-cell communication, a book that Dr. Rayon and I published in 2012. Symbiogenesis, which is actually the basis for evolution, is the assimilation of factors in the environment, a paper published by Lynn Sagan in 1967. Consequently, physiology operates based on the same laws of nature as the cosmos. Consciousness is our awareness of cosmologic laws of nature. It is why we feel that there is something greater than ourselves. So here I'm explaining the idea that, so in the beginning, we know there's fossil evidence that a snowball-like asteroid struck the surface of the Earth and generated this ocean that covered the Earth, beginning about 100 million years after the formation of the planet. The poets always eat our lunch here, so Robert Frost said life is that which can mix oil and water, and he's correct. That's what I'm talking about. So I maintain that in the context of Bohm's wholeness and implicate order, that prior to the existence of life, there was only an implicate order. And then the cell membrane delineated the difference between the explicate and the implicate orders. So life actually is what set the tone, set everything in motion in terms of what we understand as our reality. So how does this work? So Earth's gravity so lipids are produced by pulsars in deep space. And floating on the surface of this ocean covering the Earth, these lipids are what are referred to as amphiphils. They have a positive and a negative charge. Gravity causes these lipids to stand vertically at the air-liquid interface here, with the negative charge sticking down into the water. That's the hydrophilic end of the molecule. And once there is adequate negative charge to neutralize the van der Waals force of surface tension, these lipids will spontaneously form micelles. And that actually is a quantum shift. There's no in-between step here. It goes right from molecules to a micelle. A semi-permeable membrane is surrounding space. It's also a phase transition. And so that gave rise to primitive cells. And as Schrödinger says in his What is Life, the essence of life is negative entropy within the cell, fueled by chemiosmosis as a source of energy, and that's all controlled by homeostasis. So more deeply into this, it's the same depiction, but I'm adding the idea that, an experiment that I ran back in 2003 demonstrated that gravitational force is necessary for this entire process of the induction of life. If you put differentiated cells in zero gravity, they lose their phenotype. But they're not dead. You can reinstate their phenotype by putting them back into unit gravity. And the other principle that's involved here the energy that is generated by the gravitational force based upon Einstein's field theory produced the energy that sustained quantum entanglement at the very origins of life, allowing for particulates coming into the cell through the semi-permeable membrane to be stabilized. But that also refers, that's the local effect. The non-local is referring to the gravitational force in the cosmos. But the other orientation here is the first principles of physiology, which I just rattled off. That's important because that's the reference point for all of evolution, as I'm showing in the far right here. So I'm just going to show here how this works for lung evolution. So as lungs evolved, this surface area in the upper right here became smaller and smaller. And that represents the phylogenetic change from the swim-bladder fish in the lower left-hand corner here of this Cartesian coordinate to the amphibian lung, the reptilian lung, and then ultimately the mammalian lung. And that's underpinned by cellular communication mechanisms shown in tandem, in which these pink cells or muscle cells interacted with epithelial cells to allow for this decrease in alveolar surface area, and basically allowed for the production of lung surfactant, which maintains the alveolus intact in the face of ever-increasing surface tension. And I'm relating that to, I'm using Einstein's E equals mc squared to say that in reality, all of this phenotypic change is actually forms of energy. So I'm showing the regressing alveolarization against time on this right-hand coordinate as evolution. And as evolution has progressed, this actually is a series of high-energy phosphates. That's what organogenesis is, terminating in stable or homeostatic physiology. And that actually relates back to the origin of everything based upon the Big Bang, if you will. So I'm quoting Pythagoras, so actually, man is said to be the origin of the measure of everything, but in fact, I'm saying that the cell is actually the measure of everything. There was no explicate or implicate order until life began. The cell as a topology, partitioning the implicate order, literally forming the interface between the outside and inside of the cell. Therefore, math and physics are superseded by biology, unlike Rutherford's statement that all science is either physics or stamp collecting. Husserl's paper, The Origin of Geometry, published in 1936, similarly says that the same thing about math being external to biology, which I fully agree with. So I'm depicting what symbiogenesis is in the top row of these X's and Y's. So basically, these are emergent steps in evolution of the cell to, unicellular life dominating the Earth for the first 3.5 billion years. Multicellular organisms have only existed for about 600 million years. But as these existential threats have been posed, challenging life, what has happened is through symbiogenesis, there's been an internalization and assimilation of factors in the environment. And Margulis used the bacterium as an example of how that became part of and parcel of the physiology of the cell as mitochondria. But that whole scenario goes on and on. It's never ending. And then I'm depicting here the compartmentalization of these assimilated factors. And I'm showing how that all was set in motion, as I said in the previous slide, by the local gravitational effect on the cell and quantum entanglement through the energy generated by gravity locally, and in reference to cosmic gravity, which is the non-local aspect of the quantum entanglement. So here showing the Big Bang, depicting it on the left, I have stated in print that this was given rise to from the singularity, which is shown in the far left of this schematic. And then that singularity gave rise to the Big Bang as a vector through this explosive event. But there was an origin, and that's important to realize. And that's Penzias's work on the redshift was the first indication that we knew of the fact that the cosmos originated from a point source, if you will. And I'm showing this vector on the far right. So the title of the talk was about latticework, and so I'm showing, for example, here on the top set of schematic that stellar evolution, the generation of light from stars, generates the elements in the order in which their atomic number increases from 1 hydrogen to 36 iron. And this is the primary latticework of physics. And that, in turn, is used by biology as a template for the latticework of biology. So, for example, the thyroid gland was given rise to from invertebrates, lampreys, through this structure called an endostyle. It's a structure in the throat of the lamprey that filters out stuff in the water as it's feeding. And in turn, the endostyle became the thyroid through these cellular mechanisms I've been describing. And ultimately, the thyroid was able to utilize iodine, atomic number 53. So you see there's a gap between 36 and 53. But the biology entails both the history of the organism and also has memory. And so that's why the organism was able to create this biologic latticework, mimicking the latticework of stellar evolution, for example. Similarly, gravity has been claimed and hypothesized to be the basis for planet formation. So particles in space condensing as planets. So you have the same force of gravity influencing and determining both life on the planet Earth and also the planet itself, which I find intriguing because that makes a lot of sense in retrospect in terms of, for example, just to put a point on it, Lovelock's idea of Gaia, for example. And so, again, I'm showing the symbiotic process, and I'm saying that physiology, which was given rise to by these symbiogenic processes, is analogous to planet formation. And that furthermore, the utilization of particles in the environment is a binary. So the cell membrane is making decisions as to whether some substances should be allowed in or not. That's a binary. Whereas physiology is actually an analog function. It's a continuum that is dictated by those first principles of physiology, for example. And my hypothesis is that what we think of as consciousness is actually both the binary function of these particles coming into the cell, providing the substrate for the formation of physiology, and the analog function of physiology itself, relating to cosmic consciousness because the aggregate of the physiologic components is actually the utilization of the same laws of nature as the cosmos is utilizing. So evolution, oops. Sorry, I can't see what's going on here underneath. I guess I have to skip down to the next. So it's been determined that it's the context of the environment striving to reestablish homeostasis that is the driving force behind evolution. If evolution were random, it would not have been possible to trace the stepwise cellular and molecular emergences that constitute vertebrate evolution. So contrary to Darwin, evolution is a combination of probabilism and determinism in service to homeostasis, providing a mechanism for Maturana and Varela's classic description of autopoiesis, or self-referential self-organization, which they did not explain mechanistically, but which I'm providing an explanation for. Okay. So the experiment that I did, so I'm referring here to the phase transition from lipids to non-cells as a quantum leap, as I described earlier. So if you put cells in zero gravity, it causes them to lose their phenotypic identity in vitro and in vivo. So I had the good fortune not only to use a NASA-approved device to mimic microgravity, but also received bones from rats flown out in space for a couple of weeks. and published that paper in 2003. So that was the experimental evidence that gravity is necessary for phenotypic expression of identity of cells. Krishnamurti, in his dialogue with Bohm, told him in the 1983 Brockhurst Park conversation that in order to reach the cosmos, Bohm had to relinquish his ego. And I'm maintaining that I'm equating ego with phenotypic identity. So he's saying the same thing. The loss of cell-cell signaling during aging and senescence is the loss of physiologic identity, or ego. Major, in a publication in 2013, for example, a study, he's an anesthesiologist, and he showed that patients recovering from general anesthesia actually experience a recapitulation of brain phylogeny as a correlate of this idea that, in fact, the brain has evolved over the course of time in response to the evolution of the selection pressure. Kubler-Ross is well known for work on near-death experiences associated with seeing a point of light at the time of death, and I'm suggesting that that's the transition, hypothetically, from the non-local to the cosmos, and that we ultimately return to the singularity in the course of our lives, energetically. So the body can remember trauma, for example, and that answers Chalmers' 1995 question as to why it is that we see red when we're injured. And I'm suggesting that that's innate. It's referring to the first time we bled having an intact, closed circulatory system. So it's an atavism. And there is evidence that the cell can remember experimentally. So the receptor gene duplications, as an example, receptor genes duplicated in the water-to-land transition about 500 million years ago, and that changed the physiology of the lung, for example, from a swim bladder to the pulmonary, to the lung, and that, for example, was a duplication of the parathyroid hormone-related protein receptor. And similarly, these other two receptor duplications, that of the beta-adrenergic receptor and the glucocorticoid receptor, are essential for the transition from water to land. So again, these duplications or amplifications are representative of the memory of the system, because if you, there are pathologic conditions in which these signaling mechanisms are lost, and there is a simplification of organ physiology. Okay. So the mathematics of the cell membrane is a Mobius strip. I'm excerpting this from a paper by Klein and Neyman talking about their soft logic mathematics, published in 2021. So, quoting them, we proceed to define a new soft coordinate system. This creation of a geometrical space allows the visualization of various processes. This system also enables us to present soft numbers in an infinite strip and create the Mobius function, which shows the geometry of the space. The Mobius representation allows local antagonistic points to become the same globally, thus mathematically capturing one of the mysteries of consciousness, where differences may be transformed into unitedness. Concepts of duality and non-duality can coexist depending on the observer's context. So the equations that I'm going to refer to here bridge the Cartesian coordinates, x and y, to a point on a Mobius strip. So they call this map a soft Mobius map. The significance of this map is that it transforms the points on the plane into soft numbers that are represented as points on the Mobius strip. Each colored region is mapped to a corresponding region on the Mobius strip. So, as predictions of this mathematical model, if the soft Mobius map of real and complex numbers corresponds to local consciousness, the complex numbers alone should correspond to the non-local consciousness of the cosmos. And furthermore, the cell in unit gravity represents local consciousness, or what Bohm referred to as the explicate order. The cell in microgravity, as I referred to in my experiments, losing their identity, I think hypothetically is the non-local consciousness, or the implicate order. So this is Klein and Neyman's soft coordinate system. So on the left are different levels of 0, in both negative and positive values. On the right are real numbers. And what they're doing is they're merging the real numbers, with these levels of 0 to form complex numbers. And so what they do in this paper on soft logic is they colorize that image that I showed earlier with blue, yellow, green, and red. And what they're doing is saying that these various values project from this soft Mobius strip. This set of values of zeros and real numbers projects onto the Mobius strip to generate the surface of the Mobius strip. And I'm suggesting that the cell membrane of the cell, as a semi-permeable membrane, does the same thing. The mathematics and the cell physiology both reflect consciousness. So, what is the origin of consciousness? I've mentioned symbiogenesis numerous times. It's depicted here on the left. It emerges from this relationship between quantum entanglement due to the effect of gravity generating energy as local consciousness. And that in turn refers to the non-local consciousness of the cosmos, and the gravity of the cosmos. So that, working backwards, is the source of the symbiogenic process. That is the driver for symbiogenesis. So the Mobius strip property is not literal. So it's not taking a strip of paper and twisting it and reattaching it. It's figurative. And that's due to the porosity of the membrane creating no inside or outside for the cell. And here I'm diagramming the same idea. On the left, I'm showing the relationship between the non-local and local characteristics of the gravitational effect on the cell through quantum entanglement, giving rise to physiologic evolution through cell-cell communication. On the right, I'm explaining various well-known phenomena like near-death experiences, out-of-body experiences, meditation, the runner's high, and death itself, as the reverse of the physiologic trajectory of reaching from the unicellular to the multicellular state as an analog of for the binary particles that have been incorporated through the cell membrane. Yeah, so I can't read the top of this thing. I'm sorry. So with the way for the physiology, starting with the accumulation of factors in the environment that pose existential threats, followed by their compartmentation and linkage via cell-cell communication mediated by cellular growth factors and the receptors. This is the fundament of the cellular communication principle. So this way of thinking about consciousness is consistent with the idea that consciousness is the aggregate of our physiology, acting as the memory of our evolved history. And I've published numerous papers on this concept. It is consistent with the description of consciousness and subconsciousness in the Jungian or Freudian or Adlerian, et cetera, way of thinking about consciousness. It is also consistent with the Libet experiment published in 1983, showing a 300 millisecond lag between the response of the brain to a stimulus and the physical response, as if consciousness were initiated within us first, action coming after the fact. And so I'm heuristically suggesting that this may be a way to actually dematerialize and rematerialize as depicted in Star Trek. I know it's fanciful, but hey, it's only electrons. So, is this the beginning? I don't know.
Yeah. Well, I like the idea of Star Trek being the beginning. Anyway, so any questions from this whiz-bang tour through biology, physiology, and the cosmos? Well, I had a question. I know. Let me go and get my notes. Yeah, I mean, you said that you saw this relationship with the Möbius being related to the idea that there's no inside and outside for a cell. And I mean, it seems to me that there's a very definite inside and outside for a cell.
I'm saying functionally it's a Möbius strip. So the way I got to that point in the questioning of the interrogation of the physiology was through tracing sequential emergent properties of physiology until I got to symbiogenesis. And so the question was, what was the origin of symbiogenesis? And that's where I came up with the idea of quantum entanglement being the basis for symbiogenesis. And once I accepted that idea that we were connecting to quantum mechanics, which has never been done before, it's always been done synchronically as something that happened in real time, but quantum mechanics is the fundament of biology. So once I came to that realization, that suggested that the cell was openly interacting with the cosmos. It wasn't limited. And that's a function of the porosity of the cell membrane in actuality. But it's also due to this relationship to quantum mechanics and quantum entanglement.
I think you can also think of it in terms of the ontogeny. Every multicellular organism begins with a single cell that subdivides and subdivides and subdivides, and there's always sort of an active relationship between the new membrane that's created in the subdivision and the two parts of the parent cell that it's subdivided into. So then you get specialization into organs, but there is still that rich, we can think about it in terms of the last conference as distinctions being drawn in this initial cell, and the relationship between the subdivided regions having to maintain some kind of informational totality. And then the interior and the exterior of an organism begins as a subdivision within another organism, so that there is somehow a maintenance of the continuity with the rest of the cosmos as well.
Yeah, I agree with that, but I think the irony is that we return to the single-celled state in order to remain approximate to the singularity, in my opinion. So I get that idea from the work we do in my laboratory in epigenetics, basically finding that the phenotype is actually an agent for collecting novel changes in the environment. So in reality, we think of life as being complex. It's not. It's actually it's persistence of the unicellular state and maintenance of that state, because it is the functional singularity, the biologic singularity. So, but that's somewhat metaphysical, I know.
Yeah, no, it's interesting. And Mark wants to say something.
Yeah, thanks, John. I think, particularly given the audience that we've got today, because I mean, I'm obviously truly fascinated by these ideas. There are things that catch me out, and I think endosymbiosis is a strange idea to get your head around. The idea that there's stuff out in the environment and magically, somehow, it ends up inside a bubble, and that bubble reproduces the bits that used to be outside in the environment within it for perpetuity. That, you say, is a quantum process, and I just wonder, particularly given who's here today, if we can step through exactly how that might be defended as a quantum process, because I think that's the key. That's a key step in your argument, isn't it?
Yeah. So my realization is that that transition from the individual lipid molecules to the micelle is a quantum change. And so my thinking has been influenced by the work in my laboratory at UCLA, in which we study epigenetics. So that's all. So the mechanism of epigenetics is collecting what we refer to as marks in the environment, assimilating them in the egg and sperm. These are stem cells. So those stem cells in the gonads actually represent. They're the equivalent of the micelle. They're a very primitive structure, and so in that sense, I would equate it to the quantum mechanical state of this.
So what do you mean when you say that?
I think so. The fact that these stem cells, the egg and ultimately what are the egg and the sperm, those are stem cells, and therefore they are undifferentiated, and they refer back to the full state. Which I'm saying, my cell actually is a quantum mechanical representation.
All right. So it's what we want to do, and Lou's just asked the question. It's the question which I'm asking really as well. Is in what way do we mean this is a quantum process? What do we mean by this?
Well, as I say, I mean the transition from individual lipid molecules to my cell, as I described it, through the effects of the lipid charge on the van der Waals forces, that loss of surface tension allows for a quantum leap from individual molecules to a micelle. That's why I think it's quantum.
So what's the key concept there that makes it quantum? Is it the leap, that change of state? That's the key concept that makes it quantum for you.
Yeah, it's a phase transition, actually.
Okay.
Yeah.
Or a Whiteheadian prehension, maybe.
Sorry, Nicola, what was that?
Maybe a Whiteheadian prehension. This was Nick Rossiter has been giving a talk on Whitehead and the category of the ultimate. When he so looking at Whiteheadian terminology, which may or may not be helpful now, but is probably interesting to bear in mind for some of us anyway.
So I'm basically trying to back into my experiment with gravity, which clearly shows that the differentiated cell requires gravitational force in order to maintain its identity, its phenotype. So the only way I could understand the effect of gravity on a cell was through the Einsteinian idea of field theory, generating energy to what end? Well, that was in order to maintain the quantum entanglement within that primitive prototypical cell. Right.
Okay, so I'm just... Lou, do you want to say something? I mean, I'm just reading your messages here.
Yeah,
but, I mean, these are really important questions, and I just think...
Better get unmuted here. Yeah, well, the question is, what do we mean by quantum process? We may have a number of opinions about that. Like the orthodox use of the term is the quantum process is a unitary evolution of the wave function, but we also, in this kind of speaking, are including observations. And the leaps occur at the point of observation. The leap occurs from going to to a new eigenstate when an observation happens. And then you have the question, who or what makes for the observation? And this is a long discussion, of course. And also, quantum leap is not necessarily a phase transition, although a phase transition is indeed a kind of a leap.
Yeah. So, as you're saying, I mean, I understand. And I'm basically trying to understand how the empiricism matches up with the evolution of physiology. So, so I'm acting as an observer, and but it seems to hold up and generates testable hypotheses. So I guess in that sense, rather than the traditional way of thinking of consciousness as the brain, which I find absurd. I mean, all organisms are conscious. That was the conclusion of that Cambridge 2012 meeting in honor of Francis Crick, that all organisms are conscious. And this is the way that it needs to be thought of. It's because of that continuity between the laws of nature and physics and the laws of nature and biology.
What do we refer to when we talk about consciousness? We're always, in normal conversation, scientific conversation, we're really referring to much more than a given brain or a given collection of brains. We're referring to something that we participate in involving the whole system.
Yes.
And it's difficult for us to define it exactly because we are part of it.
Right. So I published a paper on the central theory of biology in which I actually had considered the real possibility that, for example, when we meditate, we actually go back in biologic historic time, all the way from the brain to the gut brain to the skin brain. And there's ample evidence that, all those states of consciousness existed over the course of evolution. And so it's a way to understand. And the key was that during meditation, physiology is diminished, right? You have decreased blood pressure, decreased adrenaline because of that, decreased body temperature, et cetera, et cetera, et cetera. That's the obverse of what happens in a stressful condition, which is what's giving rise to the physiology of vertebrates, at least, and probably all organisms. But the data are not as rich as they are in vertebrate physiology because of medicine. So yeah, so we're limited in that sense. But I propose that it would be productive to think in these terms rather than to be tethered by these ideas of, it's only what's between your ears that's consciousness. I just don't buy that.
So, would you want to think about states of consciousness in relation to very elementary biological systems, like there would be a state of consciousness related to a single cell or protocell?
Sure. Yeah, a German scientist has shown that if he puts a little glucose in the water, the paramecium will gravitate towards that sweet taste, if you will. And there's a calcium flux that occurs in response to that. That paramecium is conscious of that glucose. It's no different from, if somebody put glucose on my tongue and I was in an MRI machine and you can see my brain light up. It's one and the same thing. So yeah, I think we have to break out of the parochial ways we think about consciousness that, tether us to the ego. It's what Krishna.
Well, I think it's absurd to try to think about consciousness as being produced by some mechanism. But on the other hand, it may be fruitful to try to think about it, even though it's absurd.
Absurd in what sense? It can't be.
Well, you get a contradiction. You say, I have a mechanism in front of me. I have this beautiful program that plays chess better than I do. A little tweaking and it will become conscious. A lot of people think that way, or the fellow who thought that a conversation program was becoming conscious because he started interacting with it. So a lot of the things that we associate with consciousness are habitual patterns of interaction that we have, and it isn't that.
Right, I agree.
And every time you ask what is it, it isn't that.
It's emergent, and that's how I got to where I got. I maintain that a computer can tell a joke, it can't make a joke up. That's an emergent property. You can't program that.
Watch out, you might find a humorous computer coming your way.
There's a humorous Isaac Asimov story where they're programming this big computer, the ENIAC or whatever they call it, and one of the it's supposed to be artificially intelligent, and one of the engineers really likes to tell jokes, and he has this big compendium of jokes, and so he programs into the computer all of these jokes and has it derive some purpose for this humour or some explanation of where these jokes come from, and it spits out an answer that I'm probably not doing it justice here, paraphrasing, but that they're an object to study human beings, and then the second consequence is that if this was discovered, it would no longer be useful, and suddenly he can't think of a joke, and he thinks if he goes home to read one, he won't find it funny anymore. It's just a kind of Twilight Zone kind of. I think it ends on the line. Suddenly, the entire world shrank to the scale of a laboratory.
Yeah.
It does seem to me that we do require a quantum explanation for endosymbiosis. That would be a very interesting thing to, a detailed description of the mechanism, which would satisfy, Peter, and Lou, and Dirac, and, goodness knows who else we talk about here. I think it does seem a remarkable thing that, first of all, endosymbiosis does seem to be true, and secondly, it's very weird. Now, I mean, one question, John, I think, just to think about the observer question, because one of the things that you particularly made a big point of is the fact that the cell boundary is really the first observer. It's that sort of division between the explicate order, which is the world of living things, effectively, and the implicate order. Does that take us some way to this, do you think?
Well, yeah, I mean, I'm of the opinion that if it's not relevant to life, it isn't. It's metaphysics. It's not relevant. We have to limit, the ideas we have about the physics and the mathematics to make it relevant to life form, because that's what established the relationship between the explicate and implicate orders.
Okay, so just following a train of thought then, if a quantum leap is observer dependent, is there a necessity in the theory or is it reasonable to speculate that there must have been a first observer, and the first observer must have been the cell, which is not a million miles away from what Husserl says, really, with regard to geometry?
I'm of the opinion that whatever the singularity is, that's the first observer. That's the origin of everything. And I think that the purpose of life is to reproduce what the Big Bang has already generated. Because, for example, we know the sun is going to burn out, but we created fusion, right? So life forms have been able to mimic what physics has generated and perpetuate it. And I think my sense is that that's what the purpose of life form is, particularly human beings, specifically human beings. Okay, so I'm saying that singularity is the observer, the life form is the observer, but it in turn emulates the singularity in order to close that loop.
I mean, there's a chemist in Glasgow. John, do you know Lee Cronin?
You've got to come in from here, isn't it?
It's the lag and volume.
You're muted.
Laurie would like to come in.
I'll wait.
Yeah, okay. He said that life is basically the cosmos creating a memory for itself, which is an interesting idea.
Just to
John, hi. Can Laurie come in? He's been waiting.
Just to give us start for a program of understanding how endosymbiosis is a quantum event. From the Bohmian, the implicate and explicate order, this arose from his belief that the universe is a majestic hologram, in his words, that every part contains the whole. And we can make this very mathematically precise, and the precise specification for it is that the information contained within a volume and out with a volume on the outside must be in some correspondence with information on a surface, or in the cellular case, on a membrane. And because of this perfect correspondence, that's how a holographic plate can replicate something that appears to have volume. And so we already have, this is one of the areas in which gravitation has met with quantum physics through black hole thermodynamics, the fact that the entropy of a black hole is proportional to the surface area. So everything that falls into it, all of its complexity, is living in a surface of one fewer dimensions in ponderable space. So one could imagine that the ultimate observer would be the entire cosmos, self-observing itself, but then that is then reflected on any kind of functional division of the cosmos.
Yeah, it's Bekenstein's work on black holes. Yeah, I think that the black hole may have been the prototype for the cell. But what I'm saying about the cell is it's a self-contained unit. It has the capacity for homeostasis, meiosis, and mitosis as a function of its context. It can do all of those things.
And in endosymbiosis, you have two organisms that are performing homeostasis, one with respect to another. If in the event that generated eukaryotic life, there was the definition of symbiotic is that what's happening for the smaller organism that's been subsumed by the larger organism, they're maintaining a mutual symbiosis with one another.
Okay. Right.
John?
I think this goes right down to the level of elementary particles. Every object with respect to every other object. Every object's embedded in a system where it's communicating with all other objects in the universe, right down to the elementary particle level. And that interaction is a continuous interaction, which is partly defining what the properties of those things are. The 1 Newton in the case of the electron, or the 1 ton in the case of the nucleon. There's an interaction with the rest of the universe going on for everything. And I think what's happening as we evolve is we're simply becoming more and more aware of that process, and more and more able to tap into that process and to see how that works. So it's happening at every level. It's fractal right down to the size of individual elementary particles. I think John's right to say the first event was the creation event, the initial creation event, because as soon as you have two things, they're looking at one another. We don't have 2 anymore, we have 10 to the 80. And they're all looking at one another, all interacting with one another all of the time, some of them in symbiosis, some of them in complex systems such as ourselves. But nonetheless, the basic process is the same right the way up and right the way down. So that everything's in communication with everything else here and now. In my view.
I don't know that anyone else has suggested that there's a continuum from the local to the non-local biologically. I mean, there's a lot of work on non-local consciousness. You know, that's kind of woo stuff, but I think it's real, and I think it is the yang, it is that balance between the local properties of the cell and the non-local properties of the cell.
Well, you know some people here who suggested that, because Peter has, I have, suggested these things are what Feynman did. Feynman and Wheeler suggested that one needed to have a connection between local and non-local in a paper in the early 50s. So it's not the only place that it's been done. It's been around for some time, this mutual interaction thing. There's yes?
And John, when you start to talk about non-locality, then you run into different kinds of non-locality as well. It can be the pure quantum non-locality, apparently, but then also if you're in a critical statistical mechanical situation, then you have non-locality arising because everything is communicating with everything else.
I think that's right. I think people would think about locality in something as being close to. But of course, locality has nothing to do with being close to. It's to do with being close to the light cone. As you get close to the light cone, then you're truly getting closer to things. And of course, most of our interaction with the universe, at least outside the planet, is on the light cone. So that's really here and now. That's zero distance in terms of the interaction frame. So one has to be careful with locality not to confuse one's monkey self. So that just means here in the living room. It really is over the whole universe in terms of things that are interacting at the speed of light. And
I appreciate what you said, but I'm sorry, okay, I just want to say that, but what I offer is a connection between all the data I've talked about, other than this question of, what's beyond all this. It's all experimentally demonstrated, and it is our physiology. So there's a connection between our physiology and the non-local. That, there's a bridge there, and it offers testability. Popperian demonstration of
John, just a quick comment on that. When you look at the quantum mechanics as it, in a sense, emerges from Minkowski space, you actually notice that what the wave function is really, it's a mapping in space of the history of the particle. And quantum mechanics does that right? It does a perfect job of that. Now, if you're thinking about using quantum mechanics in such large systems, you have a problem scale. How on earth do you have such a fragile, perfect reconstruction of history in sort of wet environments? It's in a sense scale against you. On the other hand, if you can mimic the idea that in a sense an object can talk to its past self through space, through spatial fields, then you have, in a sense, a sloppy version of quantum mechanics. And I mean, there are other systems where quantum mechanics sort of reappears in funny places where you wouldn't think they would. There's a renegade Frenchman in the trial who has piled done lots of numerical analysis on the distribution of planets in solar system and so on, and he does a better job with the other models, but he invokes quantum mechanics, which, in a sense, he doesn't really need to do if he looks at the way that Minkowski space itself has this feature that the non-locality is actually a feature of, in this case, the Lorentz transformation. But in other cases, if you had any mean field approximation to a Lorentz transformation, you would have some of the features of quantum mechanics that you might be able to use in a different context.
I think that's a very good point you bring up, Garnet, and the thing is that quantum mechanics is not just one thing. It's really a couple of things. One of them is the quantum side of it and the exchange side of it. But the other one is the wave nature of it, the wave harmony that sits within quantum mechanics. And that's really common with quite a lot of other systems. So if you're looking at planetary systems and so forth, there are waves, there are oscillations, there are harmonies within those as well, which really follow the same mathematics as the wave part of quantum mechanics. But then on the other hand, why should really one distinguish between these? Because if the wave is forming what's happening with quantum mechanics, it's also forming what's happening with the planets. Aren't we really in the same theory?
Well, the thing is, in some cases, I think we really do have to distinguish, because, of course, with quantum mechanics in its current state, everybody gives up the collapsible wave function, and you don't really want to have.
Hey, I don't.
Well, okay.
Garnet,
Yeah.
I wanted to ask you about what you meant by the perfection of quantum mechanics. Do you mean its perfection resides in that the history of any given situation consists of all possible ways to get there?
In a sense, if you look at that from the point of view of the path integral, but even if you just back up and say, throw away quantum mechanics, just look at the Lorentz transformation, and look at what the Lorentz transformation does. And you say you've got a discrete process. As we just saw in that little diagram, it beautifully maps out the Schrodinger propagator, and that's not quantum mechanics. That is the Lorentz transformation. The fact that you have time dilation which stretches stuff, it's the stretch that gives you the phase that comes back into quantum mechanics. And if you get a system in which that is promoted in some particular way, you have something that behaves just like quantum mechanics. I mean, helium-4 is an example of just that, right? I mean, what happens is as you cool stuff down, the de Broglie wavelength in the end overlaps it becomes greater than the mean free path of the Earth itself. So the properties that are so perfect for quantum mechanics overrun the property of the fusion equation, which says we are all these particles, but luckily they are distinct particles, so you just get the fusion equation. If you sink this thing down so that the Broglie wavelength overlaps the mean free path, lo and behold, you get this, basically Bose-Einstein condensation, and it begins to look like, this is just one quantum system.
But you don't need a Bose.
I'm just trying to isolate, I'll say this quickly, one notion of quantum mechanics. I imagine I'm in a category of a certain object, and I consider all possible arrow compositions that can take me from an initial object to that object. And that is the perfection of it. And then to somehow integrate that to get a quantity is what quantum mechanics tries to do.
Yes, but the very clever thing that happens is that in the end, you don't need to put the stochasticity. All of those combinations, which are perfectly beautifully delineated in your paper with Pierre, all of those numbers, the counting numbers, in the end, you could construct essentially the same thing by completely mechanical process that obeys the Lorentz transformation, and then softened, right? And that softening gives you the propagator. So, in a sense,
wait, one more question as long as you brought it up. Then can you generalize that to the Feynman path integral in general, where you look at all possible paths and then you look at the phase corresponding?
Yeah, you can. Yeah.
I'm sure you can, though.
You can. What you need to do is, the Feynman path integral has nothing necessarily to do with quantum mechanics. We're just talking about something which has a transformation, and which has an action that takes all possible paths in space, and you're looking at the sums of those, looking at an extremal action. So we're not talking about quantum mechanics here, this is classical. And yes, you can generalize it. So if we go to, for example, a checkerboard pattern, and we start shrinking the thing down, what we're looking at is we're looking for an interaction. We're looking at something that's going both forwards and backwards in time, but that has different scales. So if there's interaction from A to B, a hot object to a cool object, photons being emitted by something and absorbed by something else, then you have one high energy part to that interaction if you're looking at the advanced and retarded ways. We also have a low energy part to that if you want an inverse to that. The inverse of something big is something small. The inverse of something large energy is a small energy. The inverse of something of a small size is a large size. So you're looking at both of those at once. So you're looking at scales which vastly start encompassing things which are larger than such things as the mean free path. You don't need to go to a Bose-Einstein condensate. I was looking at systems in fermionic systems and electron systems where the mean free path was also, where the de Broglie wave path is also much larger than the mean free path. So you can do it for single particles too, why not? You just need to make things cold and make sure that the scattering is restricted, which you can do if you go to lower dimensional systems.
Hey
So
guys,
in those cases, then you're looking at coherent quantum systems over the whole of the object.
Hello, we need, We've actually got to decide some things here in this meeting, and we've kind of overrun. I think we were late behind, and I think we're now, so.
Can I just interject? Trying to raise the issue of coherence. And I know that's a knock against this idea of quantum mechanics and biology, but I'm of the opinion that the cell actually achieves the ability to interface Newtonian and quantum mechanics. That's what's been shown. And I'm not the only one who's shown the effect of gravity on a living form. There's a group from Boston University who showed the same with yeast. So it's a real thing, and experimentally, Daniel Fels, a Swiss scientist, has shown that one photon can induce cell division. It's a real phenomenon. So then the question is, well, how do you...
John, I'm not actually...
So thank you, John. Thank you. That's, fine. Okay. Okay.
John, can you post your email and we can chat?
Okay, great. So I think now we need to say thank you very much, John. And that's good if, obviously So God bless and see lots of you tomorrow, hopefully. Take care. Bye now.
Especially the speakers.